Hi, Peter K here once again. Now, a little while ago, while I was out shopping somewhere, I saw a Russian doll for sale, and it gave me an idea for a puzzle. But before I get to that, I just need to explain something about a particular way to factorize Pandigital numbers. Any 10-digit number that contains all the digits 0 to 9, such as this one, is called a Pandigital number. There's more than 750,000 of them, and they can be factored into sets of divisors, often in many different ways. This one, for example, has at least 6 ways. I'm most interested in the last set on this list, and that's because the digits of these divisors, when taken together, also contain the digits 0 to 9. In other words, the last set is a pandigital factorization of the number on the left. This number has only one set of divisors like this, but here's another with 3 sets, and another with 16 sets, and that's the most possible. Now, not every pandigital number can be factored like this. In fact, there's only about 18,000 that can be. That's still a lot, I know, but remember that is out of more than 3.25 million possibilities. From these, you can make just over 24,000 different pandigital factorizations, and they can contain anything from 2 to 5 sets of divisors. Now, for this puzzle, I'm only interested in those sets that have 3 divisors, like these, and that's because I can think of the sets as representing the sides of boxes with a pandigital volume. Even with this restriction, there's still nearly 9,000 boxes, and I'll admit that some of the boxes have a strange shape. Here's a few, for example, that resemble long thin tubes rather than boxes, but I'm sure you get the idea. Okay, so I know this is all very interesting, but what's this got to do with Russian dolls, you might ask? Well, another name for a Russian doll is a Russian nesting doll, and that's because you can split them open and place one inside the other, like this. Now, I wondered whether I couldn't do the same thing with the boxes I've described. Sounds easy, but bear in mind that you can't just arrange the volumes of the boxes in descending order and expect them to fit together. Take these 2 boxes, for example. The blue box won't fit completely inside the orange-coloured box, even though it has a smaller volume, and that's because the sides overlap. It's actually the size of the boxes that must be in descending order. Okay, it turns out to be quite easy to fit 1 or 2 boxes together like this, so then I began to wonder how many I can put together. Now, the world record for Russian dolls, I think, is 51 at the present time. Now, how many of the 9,000 pandigital boxes do you think I can nest together? I'll show you my record. It starts with this one, and inside that we can place this box. Inside that we can place box number 3, then box 4, box 5, box 6, 7, 8, 9, 10. Can we do any better? Sure can. 11, 12, 13, and finally 14. Okay, so there you have it. 14 boxes is my record, and phew, I'm glad it wasn't 9,000. Can you do any better than 14? I'd like to know if you can. What about the zeroless pandigital numbers, the numbers that contain the digits 1 to 9? Can you repeat the puzzle with that? Boxes do exist, such as this one. Anyway, I'll leave you to think about that until next time, and then I'll show you my best result. Till then, thanks a lot.